Good morning. Today we are looking at lesson 1.6, representing functions as rules and tables. And then 1.7 we will also get into today looking at graphing these same pieces of information. So first we're going to talk about what's a function. A function, looking at a table like this, is for every input there is only one output. We could also think of this like a pop machine. For every button that you push on the pop machine, you should get one thing out. The button that you push that says Pepsi should give you a Pepsi. The one that says Sprite should give you a Sprite. But if you have a button that says Sprite and it gives you a Pepsi, well, that's not going to work. That won't be a function. So let's first look here. Our domain is our input values, whatever we're putting into our equation or into our pop machine. What we're putting in is always represented by X. Domain has the word in right in it, so that's what we're putting in for X. And then our range is then what we get out. Our range is our Y values. And I like to think of the word range as having a Y right inside the G there. So our range is our output values, or our Y. Another word that represents this is our independent variable, which is X, and our dependent variable, which is Y. These are similar words to domain and range. However, domain is the actual values, like numbers, 1, 2, 3, 4, whatever. Our range is also the values, like in a table here. Our independent and dependent variable are things. Like your independent variable might be the pop, and the dependent variable might be like the cost. So those are actually words. So let's look down below here. This is a function. A relation is a set of ordered pairs that relates an input and an output. So here they have them as ordered pairs, 2, 5, 4, 7. Here's the same information in a table. So 2, 5, 4, 7, it's the same information, just showing you that there's multiple ways to show it. So if I push the button that says 2, I get something out. If I push the button that says 4, I get something out. If I push the button that says -1, I get something out. Okay, they all work. However, if I push the button that says 2, I should get a 5. If I get a 4 instead, well, that would then be not a function. So in order to tell whether something's a function or not, we're looking at the input values. They need to be different. Okay, because what we're plugging in, Pepsi and Sprite, we get two different things out. But if they're the same, if we have two different buttons that say Pepsi, for example, maybe 2 and let's say 5. If I have two buttons that say Pepsi, they're different buttons, 2 and 5 here. However, they're both giving me the same thing, a Pepsi. And that's okay, because there can be more than one Pepsi button on a machine, but one button can't give you two different things. Okay? So like that too. This one was a no-no, because that one button we pushed can't give us two different things. So let's look and decide whether or not these are functions. So remember, we're only looking at our input values, what we're plugging in. If I push the button 4, I get a 3. If I push the button 6, I get an 8. That's okay. Here's a 3, plugging in a 0, -1, 7, -2. All of our inputs are different, so yes, this is a function, because there's one output for every input. You could say for every button you push on the pop machine, you get something out. That's okay. And some of you might be thinking, well, we get out a -2 here and a -2 here. This button says Pepsi, the third button, and the second button might also say Pepsi. You both should get out a Pepsi. That's okay. They're just different buttons. Second one, we have a 0, a 1, a 2, and a 3. They are all different inputs, so same as before. Yes, it's a function. Every input has one output. Same way, or different way of saying the same thing. Alright, down below here, This is now just in a table. We plugged in a 9, we got out a 3. We plugged in a 9, we got out a negative 3. Well, that's not going to work. This is not going to be a function. Because for 9, there's more than one output. That means if I push the one button on the pop machine that says Pepsi and I get a Coke and a Sprite, well, that's not going to work. Okay? It doesn't work like that. This next one, we plug in a 3, we get an 8. We plug in a 4, we get a 5. Plug in a 2, we get a 6. We plug in a 3, we get 7. Well, here we have 3 and 3. We push the same button, we get two different things. That's not going to work. No, it's not a function. Oops, not a function. Because there is more than one output for the number 3. Alright, this next one. If I push the 1 button on the pop machine that says 0, should I get out a 2 and a 3? Well, no. This is not a function. You can't push one button and get two different things. More than 1 for 0. Don't mind my messy handwriting, I apologize. Alright, let's move on, flip over to the next slide. Now, they're not asking us whether or not this is a function, they're asking us to identify the domain and range of the function. Our domain is really what we're plugging in. In this equation, our input for x is 0, 1, 2, and 4. And then our range, what we get out, our y values, 5, 2, 2, and 1. If you don't want to write 2 more than once, you don't have to because it's the same thing. Here's the same question. A function may be represented by a mapping diagram. That's just what this is. Our domain, what we plug in for x, 1, 2, 3, and 4. And then our range, what we get out for y, 0, 1, and 2. So is this a function? They didn't ask us that. If I push two different buttons on our pop machine, they could both say Coke. That'd be okay. Alright, next. Make a table for the function using -2, -1, 0, 1, and 2 as your domain, so that's telling us what we're going to plug in. And then identify the range. So first thing it says is make a table. So I'm going to make an XY table. And they're telling me to plug in for x, -2, -1, 0, 1, and 2. So we're going to plug those in right here. This is where you need to be really careful. This -2 for x is really -2 squared. That's different than -2 squared. This would give you a -4 in your calculator. This would give you a +4 because -2 times a -2 is a +4. So we don't want that. So we have -2 squared and then -1. Well, -2 squared we just said was 4. -1 is 3. Same thing with plugging in a -1. It's -1 times -1, and then subtract 1. Well, -1 times -1 is +1. 1 minus 1 is 0. Then plugging in a 0, 0 squared, which is 0. 0 minus 1 is -1. Then plugging in a 1, 1 squared. 1 times 1 is 1. 1 minus 1 again is 0. And then a 2. Oops, not equals. 2 times 2 is 4. Minus 1 is 3. So we made a table, and now it just says identify the range. Our range, what we get out, are these values here. 3, 0, -1. 0, -1. These ones, you don't have to repeat again because we know our range is just our outputs. Let's do the same thing here. We need to make a table. Again, we're plugging in -2, -1, 0, 1, and 2. So let's plug those in for x right here. So first it says negative 3 and it's touching, it's multiplied, times a negative 2. And then we're going to add 2. Negative 3 times negative 2 makes a positive 6. 6 plus 2 is 8. Then plugging in a negative 1. Negative 3 times negative 1 is a positive 3. And 3 plus 2 more is 5. Then plugging in a 0, anything times 0 is 0. Oops. So plus 2 is 2. Then negative 3 times 1 is negative 3, plus 2 more is, there's more negatives, there's 1 more negative. If you notice, we're just going down by 3 each time. So our next one, negative 3 times 2 is negative 6. Negative 6 plus a positive 2 is negative 4. And our pattern continued there. Our domain, not our domain, our range, what we got out are the numbers 8, 5, 2, negative 1, and negative 4. Before we move on, I'm going to make a little assumption here, not assumption, but correlation between the equation and the table. So this equation has a negative 3 in it. That negative 3 is the same piece of information. That's where this subtracting 3 each time comes from. So whatever our pattern is, what we're doing over and over and over and over and over again, goes with the x. Okay? Think of it as we don't know how many times we're going to do this pattern, but we're going to do it x number of times. Negative 3, x many times. Then this plus 2 is wherever 0 is for x. Wherever we look for 0, x is 0, y is 2. So now we're going to take a table and we're going to work towards getting the equation. Write up function rule, that's another name for an equation. Oops, that says equation. That relates x and y. Identify the domain and range. So first thing we need to do, just like back here, our x's always go by ones. So we need to look, do our x's go by ones? 2, 3, 4, 5. Then we need to look for our pattern. From one number to the next, we're going up, so I know we're adding. We're going up by 1 1/2. So that's what we're doing over and over and over again, x amount of times. 1.5, a bunch of times, over and over and over. And then, this is 1.5. We need to look for a 0 to figure out what's added or subtracted. Well, there isn't a 0 for x, so we need to work backwards. 1, 2, 3, so we need to go back to 0 here. If we're going backwards this way, instead of adding 1.5, we'd be subtracting 1.5. 3 minus 1.5 is 1.5, and again would give us 0. So really this one is just plus 0. Next, again, look to make sure they go by ones. 1, 2, 3, 4. So we're going to figure out our pattern. We're going up, we're adding. 1 to 4, we add 3. That works. So that's what we're doing over and over and over. 3 x number of times. We don't know how many times. And then we need to work backwards to find 0. Instead of going to the right adding 3, go to the left subtracting 3. 1 minus 3 is negative 2. So that's a minus 2. That's our equation. Down below, this is the same information. However, these don't go by ones. So we need to figure out a way to make them go by ones. I can put a 1 in here, a 2, a 3, a 4. I could put a 5, 6, 7, 8 in there. That's a lot of numbers. Okay? But we only need to figure out what the pattern is one time because the pattern is going to continue. So I really don't care about this down here. If it's too many numbers away, I can figure out the pattern on these ones. So if I'm putting a number between here, well first between 1 and 7 is 6 numbers. So 7 minus 1 is 6. But if I'm putting one in between here, I need it to go by 3s. So 1 plus 3 would give us 4. Plus 3 more would give us 7. 7 plus 3 more would give us 10. And so on. So our pattern is 3 over and over and over again. And there's already a 0 in our table, so it's plus 1. Last, these go by ones, that's nice. Our pattern is going down this time. Instead of a positive, it says negative. We're subtracting 5. So y equals negative 5x. And then look for 0 in our table. There's already 0 there, and y is also a 0. Alright, it says you are buying concert tickets that cost $15 each. You can buy up to 6 tickets. Write the amount in dollars you spend as a function of the number of tickets you buy. Identify the independent and the dependent variables. Then identify the domain and the range of the function. So first, they want us to write a function. Another word for a function is an equation. But in order to do that, we need a table. Just like we did back here, in order to write this equation, we need a table. So I'm going to create an XY table. I know I'm buying concert tickets. I could buy 0 tickets and plug that in. How much would I have to pay? I would have to pay $0. I didn't buy any tickets. If I buy 1 ticket, that's going to cost me $15. 2 tickets, another 15 would be 30. 3 tickets, another 15, 45. 4 tickets, another 15 is 60. 5 tickets, another 15 would be 75. 6 tickets would get me to 90. But I can't buy any more because it says I can only buy up to 6 tickets. So here's my table. Now let's look at our equation. Our pattern, we just figured this out. We used our pattern to create the table. It's adding 15 each time. So my equation is y equals 15x. And look for 0. Y is also a 0. It says to identify the independent variable. What did we plug in? These are our words. Our domain and range are actually going to be the numbers. So our independent variable, 1, 2, 3, 4, 5, 6, that's what we plugged in, which really is the number of tickets. Then our dependent variable, what we got out, this is the cost of the tickets. Then our domain, they asked us, what did we plug in? We plugged in 0, 1, 2, 3, 4, 5, and 6. And then our range, what we got out 0, 15, 30, 45, 60, 75, and 90. And I give you a little hint down here. Your answer always depends on what you put in. So our dependent variable, the cost, depended on how many tickets we bought. Alright, last couple here. We are just moving on and we have to just graph these. So in order to graph this, I need to make an XY table, just like we've done in the past. And they're telling me to plug in 0, 2, 4, 6, and 8. So our equation is y equals 1/2 times x, and x they're first telling us to plug in a 0. So 1/2 times 0 is just 0. Then 1/2 times 2, well, half of 2 is just 1. Then half of 4 is just 2. Some of you are already seeing a pattern, 0, 1, 2. I can imagine 3 and 4 would come next. And if you double checked, half of 6, yep, is 3, and half of 8, yep, is 4. So let's graph these. Remember, this is our x-axis, this is our y-axis. In the middle we call that the origin, and this first one actually starts at the origin. X is 0 and y is 0. Our second point is 2, 1. X is 2 to the right, y is up 1. Then 4 to the right, up 2. 6 to the right on our x-axis, up 3. And then 8 to the right, up 4 for the last point there. All we had to do is plot the points, we're done. Here's the same information, same type of equation. Here's our equation. Let's make a table. This time they want us to use 0, 1, 2, 3, 4, and 5. So we're going to plug this in for x. Negative 2 times x, which is 0, and then add 10. Well, anything times 0 is 0, so 0 plus 10 is 10. Then plug in a 1. Negative 2 times 1 is negative 2. Negative 2 plus 10, there's more positives, there's 8 more. Negative 2 times 2, well, that's negative 4. And 10 minus 4 would give us 6. We see a pattern going down by 2's each time. So next would be 4, then 2, and finally 0. If you want to double check, you can. Negative 2 times 4 is negative 8. Whoop, I skipped one. Should be 3 here. Negative 2 times 3 is negative 6. Plus 10 would give you 4, and so on. We're going to graph these, starting on our x-axis at 0. So that would be right in the middle here. And y-axis we're going up 10, which is right at the top. Then 1, 8, x is 1 to the right, y is up 8. Please make sure to pause the video if I'm going too quickly. Pause it and go take it a little bit slower. 2 to the right, we're going up 6. 3 to the right, we're going up 4. 4 to the right, we're going up 2. And 5 to the right, 0. There we go. The last two problems here, or last couple, we are looking at just analyzing the graph. We're not actually going to solve anything or write an equation. It says, the graph shows the guitar sales in millions of dollars for a chain of music stores for the period 1999 to 2005. Important, or not super important, but kind of cool to read. Identify the independent variable and the dependent variable. So let's do that right now. Our independent variable is what we would plug in for the letter x, which is really the years since 1999. Then our dependent variable, what we get out for y, is our sales in millions. Then it says, describe how the sales changed over the period. Okay, let's do that first. What's happening as the years are going on, the sales are going up. Another word for going up might be increased or got larger or they sold more. However you want to describe that. I'm going to say, as the years went on, the sales maybe steadily increased or just increased. Then it says, and how you would expect sales in 2006 to compare to sales in 2005. Well, at year 0, this is really 1999. Then the next year here, in year 1, would be 2000. This is 2001, 2002, 2003. So it's really 1 year off from what the number says here. So the 6 right here is really 2005. So then in year 2006, right at the edge here, where would we expect our sales to be? Well, I would expect the trend to continue. So I could say we would expect the sales to be at about, and if these are going by 0.2s, about 1.4 or 1.5 maybe millions in sales. Alright, couple more. Write a rule for the function represented by the graph. Identify the domain, what you plug in, and the range, what you get out. I know this is a long video. I'm going to try and wrap it up here quick. In order to make a rule or an equation, we need a table. So I'm just going to take this information and change it and put it in the form of a table. So looking at this first point, x is down here at 0, y is up here at 5. Then at this next point, x is 1, y is 4. Then here x is 2, y is 3. Down here, x is 3, y is 2. and last, x is 4, y is 1. So writing our rule or our equation, our pattern here, we're just going down by 1. Make sure these go by 1s here too, we're good. So y equals negative 1x. And then look for 0 to find what's added or subtracted, so it's a plus 5. Same thing over here, I'm going to take this information and put it in the form of a table. These go by 1s on the bottom. These go by 5s, 5, 10, 15, 20, 25. So when x is 1, y is 10. When x is 2, y is 15. When x is 3, y is 20. And when x is 4, y is 25. So our equation, we need to look first for our pattern. Our pattern is going up by 5s. So 5x, that's what we're doing over and over and over again. And then there's no 0 in our table, so instead of adding 5, I need to subtract 5. So 10 minus 5 is 5. It did ask you, oopsies, for our domain and range. You could just list our domain are the x's, 0, 1, 2, 3, and 4. And then the range, 5, 4, 3, 2, and 1. You could do the same thing for this one, but I'm going to skip that. This is just a piece of information. We've learned how to write an equation from a table. We've learned how to make a table from an equation. Same thing with our graph. We can convert a graph to a table or a table to a graph. They're all representing the same situation. We didn't do this one, don't worry about that. Your homework is a worksheet that I have in the classroom you can grab. And then we also have to do a couple problems from 1.7, which is out of the book. You only have about 8 problems, I think, to do, but make sure you do it on graph paper and write your name on it. Good luck!